Hi and welcome to Academic Compliance Academy of Law and Economics. So in this video I'm gonna try to solve an extensive form game with the use of backwards induction. But before we can go to the solution, let's take a quick look at what is backwards induction. So backwards induction is a method that we use to try to solve these extensive form games. The method actually consists of trying to eliminating not credible options. The result that we get is a sub-game perfect Nash equilibrium, the SPNE. There can be multiple Nash equilibria in an extensive form game, but the SPNE is a credible one. You will see why when we go into the actual game. But how do we find this result? Well, we do it by following the method of backwards induction. The terminology kind of reveals the actual method, starting from behind or from the back of the extensive form game. We look at the last player in the game, analyze this player's options and preferences, and see, okay, would this player choose A or B as a strategy depending on the payoffs. When we have analyzed the last player in the game, we kind of backtrack to the second last player, and that is the method we use. At last, we will come to the first player and we will get a result. But let's look at an actual game, because then it might become a bit more clear what we're doing. So I put up here an extensive form game. It has imperfect information, which means that when player 2 has to make a choice, it is not clear what player 1 has already chosen. So backwards induction, we start from the back. Here, player 2 has 3 different strategies to choose from in this segment, in this area, and that is C, D, and E. All of these strategies are connected to a payoff. That is the number. And since it's player 2, it is the second number, which means that if player 2 chooses strategy C, the payoff would be 2, D, 0, E, 3. So of course it is very clear here that player 2 would prefer E to C or D. So we mark this and say, okay, in the first situation, player 2 would prefer strategy E because it maximizes his payoff. We now move down to the second choice situation where player 2 again has C, D, and E. However, the payoffs are not the same. Now C equals 8, D equals 6, and E equals 0, which means, of course, that player 2 would prefer strategy C rather than D or E. We're going to note this and go to the last choice situation where we still have C, D, E. The payoffs are now 1, 0, or 4, and of course, player 2 would prefer 4 to 0 or 1. So marking this last one, we move then to the second last player, here the first player, because it's only a 2-player game. And now we will analyze the choices, the national choices, the rational choices of player 1. Because look at this, now we have to look at the game. We have already analyzed what will player 2 do when it becomes player 2's turn. Knowing that, and because we know that each player can see all the strategies and can see all the payoffs, we can now look at the game from the view of player 1. Player 1 can choose between 3 strategies, C, D, or E. And given that we know what player 2 will choose, we can now predict what the outcome, the payoff of each strategy of player 1 will be. If player 1 chooses C, the payoff will be 3, because if player 1 chooses C, player 2 will choose E, and the total payoff would be 3.3, 3 to each party or each player. Thereby, for player 1, C equals 3, D equals 8, and E equals 4. Now we can just make a rational choice. What would our preferences be as a maximizing agent? Well, P1 would of course choose the one that maximizes payoff, which would be strategy E, where player 1 will get 7. So knowing this, we can go to the result. Now we know the rational choice, we know the result of the game, how the players will game, how it will end up. And that is that both parties will choose strategy E, and the result will be that player 1 will get 7 and player 2 would get 4. And this is the sub-game perfect Nash equilibrium. This was just a short video on how to solve extensive form games with the use of backwards induction. Stay tuned, subscribe to this channel, and let's talk much more about law and economics.